I've got a very useful fact up here on the board. If we're in 2 space and we're approaching the origin, a point will approach the origin if and only if, when I describe that point in polar coordinates, r and theta, the polar coordinate r approaches 0. Because remember, r is the signed distance from the origin. Okay, so if I'm in the xy plane and I'm approaching the origin, for any other point in the plane, in order to specify where I am, I have to give you an r value and a theta value. Because if r is, let's say, 1, all that tells me is that I'm somewhere on the unit circle. I need a theta value to know where on the circle I am. But if r is 0, I am at the origin. Does not matter what theta is. Okay? So I'm able to describe where we're going in terms of just one coordinate. And so it's possible, if I have something where I'm approaching the origin, to switch to polar coordinates. Let's take a look at an example. Let's say I wanted to take a look at the limit as xy approaches the origin of x cubed y over x squared plus y squared. Okay. Now, you will notice that here, the denominator is approaching 0, the numerator is approaching 0, so we've got an indeterminate form. But it doesn't look like there's any substitution I can do that's going to turn this entire thing into a function of just one variable, because I have different expressions on top and on bottom. So what I'm going to do is I'm going to switch to polar. But I want to make sure that when I switch to polar, I'm preserving continuity. This was a continuous function of x and y. I'd like to make sure that I get a continuous function of r and theta. And one of the problems with polar coordinates, sometimes it's a problem, sometimes it's an advantage, is that points have more than one name. So I could describe this circle of radius 1 as being all the points where the r value is -1 as well. But if I allow r to sometimes be positive and sometimes be negative, I'm going to introduce a discontinuity in my function. Okay, so I'm going to switch to polar with r being the positive square root of x squared plus y squared. If I preferred, I could choose to let r be the negative square root of x squared plus y squared, but I have to pick one. I'm going to consistently let r be non-negative or consistently let r be non-positive. Otherwise, if I don't specify that, I could be introducing a discontinuity if I allow r to go back and forth between positive and negative values. Okay, so if we're going to do this, you're going to write out that you're switching to polar, and you're going to write out your choice of what r is. Okay. And then let's remember how we convert between rectangular and polar coordinates. Okay. I'm going to just draw a point here, x, y, in the first quadrant. And I'm going to label that as r. That would be consistent with my choice that r is actually the distance from that point to the origin, as opposed to the opposite of the distance from the origin. And of course, there are infinitely many theta values that I could associate with that, but the simplest choice would just be this acute angle. Okay. I am going to require that you specify what you are letting r be, whether you're choosing the positive root or the negative root. I will let it be understood that we are switching to polar in such a way that we choose theta continuously as well, that I don't go from this positive angle to suddenly this negative angle and introduce discontinuities there. Okay. All right, if I have this, the sides of my triangle are just x and y. Now this picture is for a point in quadrant 1, but what's nice about this is that we can verify that the results that we get work regardless of what quadrant we're in and regardless of which polar name for a point we choose. So I can use this picture as just a mnemonic device to help me remember how to describe points in terms of polar coordinates and how to go back and forth between the two systems. So notice that here, cosine of theta would just be x over r, and that means that x is r cosine of theta. Okay. And sine of theta would be y over r, and that means that y is r sine theta. Okay. These are formulas we work with often enough that I imagine most of you either have them accidentally memorized or will have them accidentally memorized by the end of the semester, but you can always use this triangle to remind you of those conversion formulas. Notice that while this version doesn't work if r is 0, this version does. If r is 0, we're at the origin, and that of course makes both x and y equal 0. Okay, so if I do that, I can now describe this limit as the limit as r goes to 0 from the right. It's always going to be a one-sided limit if I make a choice to switch to polar and preserve continuity, because I'm always going to have r being either the positive root or the negative root. I always go with the positive root just because it's simpler. Okay, so its limit as r goes to 0 from the right. X cubed becomes r cubed cosine cubed theta times y becomes r sine theta. And then x squared plus y squared, I can just take the shortcut that that's just r squared. Okay, r is the square root of x squared plus y squared, so r squared is x squared plus y squared. I can also see from here that's just the Pythagorean theorem. If I didn't notice that, and I wrote out r squared cosine squared plus r squared sine squared, then I could just factor out the r squared, and of course sine squared plus cosine squared is just 1. So it reduces down to this. Okay, so let me rewrite that so that we've got some room to work. So notice something very interesting has happened here. I can describe the limit in terms of one variable, but I'm describing the thing I'm taking the limit of still in terms of two variables. Okay. This only works, again, if we are approaching the origin, because if we were approaching any other point, I would need to specify both the r and the theta value to indicate where we were going. Okay, so this is the limit as r goes to 0 from the positive side of, I'm just going to consolidate my r's. I've got r to the fourth cosine cubed theta sine theta over r squared. Nice, I can cancel the r squareds. So now this is the limit as r goes to 0 from the positive side of r squared cosine cubed theta, whoops, times sine theta. Okay, so I no longer have the problem that the denominator is going to 0. This is fabulous. Okay, r squared is going to 0. That by itself is not enough for me to conclude that this limit is 0. 0 is a really powerful number. 0 times anything finite is going to be 0. But if I have 0 multiplied by something that's unbounded, so that I get quote unquote 0 times infinity. I can't have that literally, but if I get the indeterminate form where one factor goes to 0 and the other goes to infinity, I don't know what I get. That's indeterminate. I need to rewrite it as an indeterminate quotient and use L'Hopital's rule. So just because one factor goes to 0, I can't conclude that the limit is 0. If this were going off to plus or minus infinity, this would still be an indeterminate form. Fortunately, this is not going off to plus or minus infinity because this is bounded. Sine and cosine are bounded functions. They both only take on values between -1 and +1. Cosine cubed, well, if I cube a number between -1 and +1, I still get something that's between -1 and +1. So this is bounded. If one factor goes to 0 and the other factor is bounded, I can conclude that the limit is 0. Okay. But if this had been tangent of theta is unbounded. For some values of theta, it goes off to infinity or negative infinity, and I don't know what theta is because I'm only saying that r is approaching 0. Theta can be anything. Okay. For some values of theta, it would be undefined. For other values of theta, it would be a really big number. For other values, it would be really small. Okay. So this technique is only helpful if you're able to get to the point where you've got one factor going to 0 and the other factor bounded. Okay, and then you can conclude that the limit is 0. Essentially, this is just a shortcut for doing the squeeze theorem. I'm fine with you just indicating that this is bounded, but stating that is necessary work. If you want it to be a little bit more formal, this is actually going to be bounded between -1 and 1. So -1 is less than or equal to cosine cubed theta times sine theta, which is less than or equal to 1. That's because each of the factors is between -1 and +1, and so any product of such factors will also be between those numbers. Okay. Sometimes the arithmetic can modify the bounds, but in this case, the bounds for sine and cosine and for cosine cubed are exactly the same. Okay, so I've got this. Now I could multiply through by r squared. R squared is never negative, so I get negative r squared less than or equal to r squared cosine cubed theta sine theta less than or equal to r squared. So I've squeezed the function whose limit I want to take in between two other functions. But now I can take the limit of the outside functions. I can say the limit as r goes to 0 from the right of negative r squared is equal to 0. And the limit as r goes to 0 from the right of positive r squared is also 0. And these are the same. So by the squeeze theorem, the limit of that middle function, limit as r goes to 0 from the right of r squared cosine cubed theta sine theta, is also equal to 0. Okay. That would be a more formal write-up of that. If you want to do that write-up, you're certainly welcome to. If it helps you to understand more why it works, totally fine. I would be fine with you just showing this much work, showing that that factor goes to 0 and this factor is bounded. But if you just get to this point and write this limit without indicating that that goes to 0 and that's bounded, and then say it's 0, that's not showing enough work to justify things. Okay, so I need to either see the squeeze theorem or this sort of shortened version of the squeeze theorem. That's essentially equivalent, because by saying this is bounded, that's saying, hey, I can put this in between two numbers, and then of course when I multiply through by r squared, which is going to 0, the outside functions are both going to go to 0.